Okay, this is our second one, and we're going to start by remembering, we're going to remember that a surd can look like this, just an irrational number on its own, but it can also look like this, or 4 root 3 minus 1. It can have two terms, but only one of them is the irrational number, something with a radical sign. Okay, so that's the first thing we are remembering. The second thing we are remembering is this. Okay, now this is called difference of perfect squares. Okay, and what you are noticing straight away is that I have a subtraction, an addition, and you are noticing that it's A and A, two like terms. In fact, they're the same. Then I am adding and I am subtracting the same term. All right. Now that means whenever it looks like this, I get a squared minus b squared. If you aren't sure about this, okay, multiply it out yourself and check it out, okay? I'm going to assume that you can accept this, all right, without checking it. So I'm going to remind us that a plus b times a subtract b is equal to a squared minus b squared, because I have a plus and a minus. I have a squared. I have b squared. All right, let's get started. So we've known that rationalising is get rid of the surd. We're going to start with an easy one. Okay, and I need to rationalise the denominator. Now, can you already think of what the answer for this one is going to be? Okay, so just have a really quick think with a small amount of information that I have given you. And are you ready to accept that the answer to this is negative 2 root 3 plus 8 all divided by 13? Okay, these are equivalent, but I have now got a rational number as my denominator. Why is it so? All right, 2 times 4 plus root 3. I'm going to do that same thing and multiply by 1. But my 1 needs to be whatever this is, and I subtract rather than add, so that I am looking at a difference of perfect squares. 4 subtract root 3 divided by 4 subtract root 3. Are you comfortable that that is equal to 1? As long as you are, we can progress. Okay, so now I have that is 2 times 4 minus root 3 over 4, and I'm going to make these really obvious, 4 plus root 3 multiplied by 4 subtract root 3. Okay, you have noticed that 4 root 3 root 3. That's equal to 2 times 4 is 8, subtract 2 root 3 over, in this case, A is 4 and B is root 3. isn't it? And my answer, is a subtract b squared. So a squared, 4 squared, subtract root 3 squared. 8 minus 2 root 3. 16, 4 squared, subtract 3. 8, subtract 2 root 3, all divided by 13. Here is my answer, and here is how I got here. Shall we try one more? Let's have 4 divided by root 6 plus 1. I'm going to multiply by root 6. If this is an add, this becomes a subtract. 1. Root 6 subtract 1. In this case, a is equal to root 6 and b is equal to 1, isn't it? And a squared minus b squared is what I'm aiming for. Four times root 6 subtract 1 over root 6 plus 1 times root 6 subtract 1. I have an add and I have a subtract. A is equal to root 6, B is equal to 1. 4 root 6 subtract 4. 4 times root 6 subtract 4 times 1, all divided by a squared minus b squared. Root 6 squared subtract 1 squared. 4 root 6 subtract 4, 6 minus 1. 4 root 6 subtract 4 over 5. Are you okay with that?